Hey, good morning, everyone, and welcome to the Python4Lib group. We meet every other week. Sometimes we are kind of an open discussion about Python in libraries, generally geared for tech services. Other times we have some really cool presentations by some really smart folks. This is one of those weeks where we've got Jeremy Nelson, and Ed might be joining as well, who have been working on a thing called Blue Core, which is a BibFrame data store. I'm looking forward to learning a little bit more about this. So without further ado, I'll hand it over to Jeremy.
All right. Thank you, David. So my name is Jeremy Nelson. I'm a software engineer at Stanford University Libraries. Stanford is one of the partners in a new effort or project called Blue Core. And I'll talk a little bit first on some of the uh, uh, what we're trying to do with Blue Core, and then I'll go into much more technical exploration of the Blue Core software stack. So Blue Core is a collaborative environment right now that the idea is that there will be this shared BibFrame data store, initially starting with BibFrame works and instances, and the I like to think of it as a sort of a progression or evolution of the work that was done for the linked data for libraries, the LD4 grants that I've been involved with. And you may have heard of Snopia, which is a linked data editor. And a lot of those sort of lessons that came out of Snopia are reflected in the design and what we're trying to do with Blue Core. So really, right now we have a number of different partners. Besides Stanford, there's a Library of Congress, Cornell University of California, Davis, and University of Pennsylvania. Uh, Altogether, we've been sort of actively developing Blue Core. It started earlier this year. We're working on a prototype, and the idea is that this sort of communal BibFrame data store can be sort of leveraged in emerging linked data workflows. And the process of that is that you'll have these sort of shared works and instances, and you can link to those through your various ILSs. Right now, we are supporting two. We're supporting Folio and Alma, and connecting and allowing this is sort of shared BibFrame based ecosystem that we're developing out. Um, so the ownership and creation of any of the metadata that are shared there's not sort of this concept of ownership for the works and instances, but we're really trying to promote the idea that you want to link to these resources instead of needing to duplicate them maybe locally in your system. Um, there's been a number of presentations, and we'll probably add this here. Uh, and really, the name of the Blue Core came out of a really early meeting that was held at the Library of Congress in the James Madison Memorial Building. And the Madison Building has divided into four cores: red, green, yellow, and blue. And because our initial meetings were held in the blue core, that's how Blue Core came about. So nothing sort of spectacular about that, but that's just how the Blue Core name came about and what we've been working on. So with that, I'm going to show you sort of our initial software stack. And let me see if I can maybe oh, make this a little bit wider. So Blue Core is predominantly uses Python throughout. So initially, we're using Fast API as the sort of the core API stack that we're using. We're using SQL Alchemy to sort of wrap around the database, and we have just a Postgres database. We're also using Airflow to sort of manage more batch and other sorts of workflows that may require a bit of time. Also supporting things like exporting and doing sort of batch updates to any Blue Core works and instances that are in the data store. We've also planned and are in the process of implementing a vector data store. And I'm sorry, let's see if I can't get this. There we go. And what's really interesting about the vector data store is we're decomposing all the triples into separate vectors that are stored in the vector data store. And doing some preliminary work with the vector data store, it's going to allow us to tie in different AI agents to do things like deduplication, validation, and provide even a general chat interface to this collection of BIBFRAME data. The triple data store, we're planning to use Melvis. Initially, we were going to use the PG vector and the Postgres, but we found some issues trying to get it deployed, at least in this prototype environment. We're using Fast AI to code out our AI agents. And like I mentioned before, we're using Fast API for the API layer in the Blue Core API. All of our services are behind a Keycloak instance. Now, Keycloak is an open source sort of authentication and authorization layer. So the idea is that external editors like Sinopia or Marva will connect through Keycloak and connect and then do their operations that they need through the API. You can interact with the technical stack or Blue Core using Jupyter Notebooks. And we've started looking at hooking up a LD4P project called the Graph Explorer to the Blue Core technical stack. I'll stop here and ask if there's any questions. Not, I can continue on.
Hi, yeah, this is Mike Andrick. What is the URL for that? I'm going to that GitHub address that I'm seeing here, but it doesn't exist.
Yeah, so Terraform is actually a private repo.
Aha. I was just because I was having trouble reading that the diagram. And so I was wondering if we could see the diagram somewhere.
Yeah. I'll export the diagram and maybe put it into maybe chat or something. But yeah, that's it does have. So right now, to give you a sense, we are just deploying this on AWS using an EC2 instance, especially in the prototype phase. But and you can see we do have, in this repo, and the reason it's private is we do have some credentials, at least for this exploratory phase. So we didn't really want to open it up to the world, but all the code that's here is available and I'll put this into the chat here. You can go to sort of the Blue Core GitHub organization, and that'll give you access to all the different repositories I have. So all our code is open source. It's just this particular repository we've closed because it's more of a how we deploy the stack to AWS or EC2. All right. Any other questions? Okay. I'll start going into some of the code here. So I'll start with the API. And here in the API, again, this is just a fast API project that uses. And there's we also have a separate repository for the models, and I can show you that the SQL Alchemy models there. You can actually get this up and running locally. If you want to upload constrained bound descriptions that the Library of Congress has provided, sort of as our initial ingestion, there's ways you can do that. And you can send it through a command line project here to load that. And here, just to get a sense of what how this is structured, we have sort of in this app. Here's the main entry point into the API. And we have basically setting up using a Keycloak middleware for fast API. And so this provides us the authorization to various routes. Then we have some different modules within the API for handling instances and works. And then we have this concept of just an other resource. And so we have a requirement to support both Marva and Snopia. And Marva, I think, uses JSON profiles to sort of constrain or construct BIBFRAME entities. And Snopia uses RDF-based templates. So we needed a way to be able to store those sort of one-offs that aren't BIBFRAME works or BIBFRAME instances. And within the API, we create an instance. Then we include sort of these routers. So these are different routes to handle things like instances, resources, and works. And we've also implemented a activity stream for resources that are coming in. So this will allow different integrations that other sort of partners may have or future partners. And so basically you can get back sort of a delta of what has changed or what has been removed from Blue Core. And those API routes are available here in this change document. So the basic route doesn't do really anything. It just returns a JSON payload to a request and just the Blue Core API. And then we have within this, we haven't extracted this out, but these are handling batches. So this allows you to do batch ingestion. Now, the Library of Congress, they provide, and I mentioned it before, these constrained bound descriptions. And what that is either a work and one or more instances that are together and sort of exported out together. And in that constrained bound description, it has all the necessary BIBFRAME classes and data to be able to generate MARC data out of. And that's how the Library of Congress sort of organizes their collections, where they've sort of migrated all of their MARC records into BIBFRAME using some of their converters. And then Marva itself requires this constrained bound description to be able to load up resources and edit works or instances. So this batch allows us to intake these constrained bound descriptions, and then from that sort of extract the works and the instances and these other resources, because the constrained bound descriptions also include sort of the minimal triples for things like the vocabularies that the Library of Congress supports, like carrier type or format type and things like that. And what also in Snopia, what we do is we have this lookup service that allows users to sort of associate things like subject headings with the Library of Congress subject headings. And in this contained bound description, we just capture a couple of triples per one of these outlinks, such that we know what type it is, and we have a label that's associated. And those all together in these packages are what the editors need. So we do have this way to post either an upload, or you can send it a URI. And then if we go back here, and if we look at, I'll show you an example of a work API route. So a couple of things here. One is that we are using SQL Alchemy. So we import a session, and I'll show you our models where we have the different models that we're using. We have the works, instances, these other resources are just sort of our baseline. And then we have, as part of this models, we also have some RDF graph utilities that are useful to do additional work. So we then, Fast API requires you to create schemas to sort of structure both the incoming data to your API endpoint as well as the outgoing data. So we have these, creating a work, just your basic work schema, and then an update schema. The basic read work API route, you send in works and your work UUID, and then we return back this work schema. And it doesn't do a whole lot. Basically, it just filters or queries the database for the UUID. And if it's done, it returns a 404 error to the calling client. And then we have a post endpoint, which is a little bit more involved. Basically, we take the incoming payload, this handle external subjects function. What we're doing is any incoming graph, so any incoming work in this case, if it has a non-blue core URI and as the main subject for the work, we then generate or mint a new blue core URI and create a BIBFRAME triple that the subject is our new minted URI, the predicate is a BIBFRAME derived from, and then the original URI. So we're able to sort of track where the incoming what the original URI or subject was for the incoming work. Then we create a new work. We have our data that comes from our payload, our new minted URI, the UUID that we created, and then we're setting a couple of date times within the record itself, created at and updated. And then we just return that new work to the calling client. And then finally, we have a put. So basically, if we're editing an existing work in Blue Core, again, we query. If it doesn't exist, then we return a 404 error. And then if the data has changed in the incoming, then we update it and then refresh the data and return that same work. So pretty simple routes there. I'm not going to show the instances because that's very similar to works. Our other resources, again, very similar to both. What we're doing is, it allows us to search for an existing other resource within the data store, and then create new resources, other resources, and then also edit existing resources. Within the API, we also have a simple command line client. The change documents, this is where we're generating those activity streams. And so these are a little bit more involved. But at the end, we are providing this as initially. And then the schemas I mentioned before, you can see these aren't too involved. So for example, if we look at the work create schema just requires the incoming data to be a string. So we've sort of followed the Sinopia pattern where we're storing everything as JSON linked data in SQL JSON-B fields. So that gives us some advantages of being able to leverage some JSON tooling to be able to do things. And the API itself can, we're planning to be able to support different serializations. So while in the back end we'll be supporting JSON LD, the clients would be able to request different serializations of these BIBFRAME works and instances. The other repository I wanted to show you is the Blue Core models. And so again, we published this on PyPhi, so you can actually install this with pip, and it is used both in the API and in the Blue Core workflows. Here is sort of the database or relational mapper, the ORM, and the different models. So here you can see we have we're using sort of polymorphism, which allows us to sort of abstract to a base class common elements, and then the individual like works and instances and other resources are based on that. So we don't have to repeat that within your model. In the Blue Core models, instances, we do have a relationship to the work that's associated with it. Then I mentioned the other resources. Now for every time you create a new resource or you update a resource, we create a version in this version table of the work and instance. And this is where we are planning to sort of connect in the vector data store, where the vectors that we're storing for the triples will come from the version. And that way, as things change, we'll be able to update the vectors and keep everything up to date with the latest version of any resource. But we also have the ability then to do change management over time, and that supports the activity stream that we want. And I see a question here. So why we're converting external subject URIs into Blue Core ones? So so this is more of a policy that was decided about Blue Core, that we would be generating works and instances with minted URIs. And I think part of the justification or rationale for that is we're starting with this baseline, but then the intention is that we sort of want to remove. So it won't, if we just use the existing subject URIs, we wouldn't necessarily. We didn't want that duplication out there. We wanted a unique URI to be resolved to dereference. There's also, we've made some policy decisions that we're not storing certain vocabularies that may be part of an incoming work or instance. And we're also doing some validation and framing of that. So it wouldn't, if we use the same subject URIs, we were worried that it would be sort of confusing if I grabbed an LOC URI, extract and pulled that description down and then compared it to its equivalent of Blue Core, they would differ. And so we wanted to really make it clear that this is a separate sort of system that may be based on this existing data, but since it's sort of a communal data pool, it's not, it would allow any of the participant institutions to be able to edit any of those descriptions. So we didn't want that sort of confusion to sort of exist out there, that these are Blue Core, and it has a certain shape, it has certain properties, and It is. It will be an open link data, so it'll be open to anybody. But we wanted to sort of to make sure that there wasn't this confusion or sort of uncertainty that what is a blue core versus a non-blue core resource. But yeah. All right. So yeah. So this is the SQL Alchemy. We and or the blue core models, and we are, like I mentioned before, using this in the API and then in the blue core workflows as well. So the other project, so if we go here, so I just want to kind of show you, actually, let me come here, and I'm going to close this because just so you can kind of see. So if right now we have on our EC2 instance, we have a development environment, dev.bcld.info. And here we just basically have three links, one to the API, one to Keycloak, and one to the workflows. So I kind of want to show you the structure of what this looks like. So I'm going to log in as admin here. One of the reasons we selected Keycloak is because the Folio project is in their new sort of major refactoring. It's going to be using Keycloak to do Folio authorization and authentication. And Keycloak is well known and used quite a bit in different projects. At Stanford, we use Keycloak internally to do authorization and authentication. So it sort of made sense to build on this tool that's already being used in libraries and does provide us a mechanism to be able to manage users and also to assign roles to those users to what they want to do. So in Keycloak, we have a blue core realm, excuse me, and this sort of scopes what activities and users can use within Keycloak. We have a couple of different clients here. We do have an API client and a workflows client, and each one of these clients, the respective Airflow environment and Fast API use these to authenticate and then authorize users that are incoming to Blue Core. We also have users. So here's our initial participants. We have, you can set up groups. So right now we just have two groups. Basically the active development team has, and so we can leverage Keycloak to do user management, and also we have these institutional groups to do things, to support things like exporting to specific library systems like either Folio or Alma. So that's really what these groups are for, is to give us those permissions. Resources, unlike in Snopia, are not tied to specific groups. So works and instances within Blue Core are, again, sort of these communal resources that any of the institutions can use. And then if they feel like, hey, this instance, for example, is something we want to have surface within our library system, then through the API triggers a DAG or workflow run in Airflow that then will export either to Folio or to Alma. And the Airflow environment, we're building upon what we built out for Snopia. So Snopia right now allows users to export Snopia resources, BIBFRAME resources to their Folio systems or to their Alma systems. And we're building upon that code to be able to provide this service for Blue Core institutions. in our workflows. Let's see if I can get in. So this is we have the various institutions. We also have the STAG, or this resource loader. And when I showed before in the API batch resources, you can, all it really does is pass through the resource to the resource loader DAG and then processes it. So let's see here. Yeah. So earlier, back in May, I guess last month, we did about a 25K, or a little bit more than that, load. And if we go into one of these successes, you can kind of see this is a very basic sort of DAG. We grab the incoming resource. If it's a zip file, we will skip it for now, but we're planning to support being able to upload a zip file with multiple resources in it. We then process it and then actually directly from Airflow create these resources within the database and then store those resources. And if we look here, this is sort of interesting. So out of this one constrained bound description, in sort of what's being passed through the XCOM DAG, we can see here we have the work, and there's the JSON LD coming through. We have these other resources. Again, you can see these are pretty minimal. And then we should, hopefully, if I see, there should be an instance running around here somewhere. But we had, yeah, here it is. So here's the instance that's getting passed through, and then the DAG takes all these and then ingests them into the database. So that is what Airflow provides us, and then we're going to be adding, like I mentioned before, other DAGs to do exports and then sort of batch updates. So one of our requirements we have is if you need to update a triple across all or many of your instances or works, you'll be able to trigger a DAG to be able to do that. And let's see, before I go on, let's see. What I wanted to show you, well, so let me just make sure that I'm running everything locally here. So I'm going to bring up here. And you can kind of see. So we have. You can bring up the entire stack and develop locally. So Docker compose. So here it's bringing up the stack. Now I know that Terraform isn't. We have that as a private repo, but if you go to yeah, let me go here. If you go into our workflows, there are Docker directions to be able to bring up the entire stack using the Docker compose there. So that's available if people want to test this out. Okay. So let's see here. Okay. That's coming up. All right. And one thing that we've recently been doing this past couple of weeks is we've been So if you're not familiar, Airflow is an open source project, Apache project. And earlier this year, they had a major revision, or a major new version, version 3 come out. So one thing that Ed has been working on is upgrading our Airflow version to Airflow 3. So that's had some challenges, but I just want to bring that up to show you. So a couple of things, let's make sure. So one thing here in this Git token, I'm connecting to the local Keycloak API, REST API. I'm using a sort of proxy developer password. It doesn't exist on our development, but it is helpful to develop locally. And so let me get that. And then if we go here, we can, if I do a Git token, you can see there's the JWT. Now I can then take that and let me do this. Oh. Okay. So if I wanted to get just that basic endpoint, here, grab this header. I'm going to just do this. Oh, yeah, that's my problem. Okay, so if we look now at our basic endpoint, and if we look at our JSON payload, we can see there's our Blue Core API. So I'm able to connect to the API. I think, Eric, do you have a question or?
Oh, no, I'm sorry.
All right.
Sorry.
Oh, you're good. All right. So to give a sense of some of the timeline, the prototype we're hoping to finish by the end of the summer. And part of the prototype will have 300,000 records from the Library of Congress as sort of a baseline. Then we'll do some testing and some user interface work to see how well catalogers that are in the participating institutions are able to use either external editors like Sinopia or Marva to do their work. And then from that, we're planning to start work on an MVP that will go through the end of the year and the beginning of next year. And at that point, part of the discussion before we go to production will allow other institutions to join Blue Core either as a full participant, or if they just want to use the data, the API will be opened up so that people at least have read access to everything that's in Blue Core. I think that's about all I want to kind of show at this point. Any questions? Well, if you think of anything, or you just want to reach out, both Ed and I are active on Slack. I just got a Slack message from Ed that he had a meeting conflict, so unfortunately he wasn't able to attend. But we would, if you have any ideas, or again. This is all the code base except for the Terraform setup code is open source. So we sort of want to encourage people to be able to use the stack. Okay, a question about Mark. So right now, definitely in the prototype phase, we're not planning to support exporting to Mark, but it is in the MVP. We are hoping to have a workflow that is built upon the Library of Congress's BIBFRAME to Mark converter, so that people would be able to initiate an export that would generate the Mark file if they wanted to import it into their local system. But again, we're trying to really be BibFrame first, and just hopefully push institutions to replace Mark with BibFrame based workflows. And this is sort of a core piece of infrastructure to be able to enable those linked data or BibFrame workflows on the various institutions. I know the Library of Congress is really eager to be able to support this, and that's why they're a founding partner in this effort. Okay. Well, again, thank you all. Ed regrets that he wasn't able to join us, but yeah. So I think relative to this group is, again, the majority of the stack is Python. So we're developing Python competencies, and the hope is that as all of you start looking at BibFrame, that some of this tooling will be able to help you, even if you're not planning to go full BibFrame in your local systems, but you want to start experimenting with BibFrame or sort of have parallel workflows that are linked database, that this tooling will be able to help you be able to do that, to sort of be that bridge or gap, or to bridge the gap between Mark and BibFrame. And there's libraries we've had decades of developing Mark-based workflows, and certainly Mark is not going away. But I think what we're trying to do is start providing a really open link data based system to really help enable future development based on linked data in libraries. So, all right. Are we involved in Ivy Plus or planning to be? I know that the other partners, including other Ivy Plus institutions, are really interested in joining Blue Core. As you can see, we have Stanford, Cornell, and UPenn as right now that are all our Ivy Plus, but specifically, I think that's part of the MVP and going to production is to really open it up to a lot of different institutions to be able to use Blue Core. So I don't think we'll be restricted to Ivy Plus for sure. Hence, we have the Library of Congress and UC Davis right now as a partner. Cool. All right. Well, thank you all. Maybe we can come back in like 6 months when we're full into the MVP, and I can actually show some of the editors and how you can use like Sinopi or Marva with Blue Core, and also be able to demonstrate some of the AI and LLM based workflows that we're interested in doing in Blue Core. So thank you all, and I think I will stop sharing.